Good afternoon, everybody. This is Rudy Shankar. I'm with the Lehigh University's Energy Systems Engineering, and this is sixth seminar for the fall series. And we have a very interesting topic being presented by Alberto Colombo with DERNetSoft, and with the application was done with a medical company, which is very well known throughout the U.S., Kaiser Permanente. And we have the honor of having Seth Baruch, who will be talking about how this technology was applied for his company. The title of the presentation is Supporting Kaiser Permanente's Energy Transition and Decarbonization. And the Alberto has been a longtime partner with Lehigh University, is supporting these projects for the last half a dozen years. Thank you again, Alberto. Your support has been really very useful for many of our students. He's the founder of DERNetSoft, has more than 25 years of experience in the software and clean energy industry. He's a co-author in multiple AI technology patents. His industry experience, technical skills, and entrepreneurship have led DERNetSoft in achieving significant milestones since inception. Now, Seth Baruch is the National Director for Energy and Utilities at Kaiser Permanente, and is responsible for KP's on-site and off-site renewable energy programs. KP's renewable program is installing more than 100 megawatts of solar generation in hospitals and medical office buildings throughout California. In addition, Kaiser Permanente is contracting to buy the energy output of more than 330 megawatts of off-site wind and solar projects in and around California. These initiatives are a large part of KP's overall strategy to get to carbon neutrality, which was achieved in 2020. Seth also manages the fuel cell programs, 35 megawatts, as well as the battery storage and EV charger programs. Kaiser Permanente has more than 1,300 EV chargers on its properties. He also raised the funding for and helped implement a microgrid installation at the Richmond Medical Center, the first renewable microgrid in the state of California. A second microgrid project at the Ontario Medical Center is currently under construction. These are very impressive achievements, Seth, and great advances by you, Alberto, and thank you again for your support to Lehigh. So I'll leave the floor is open to you, Alberto.
Thank you, Rudy. Thank you, everyone. I'm trying to share my screen so we can show presentation. Let's see. Okay. What? Come on. Okay, gotcha. Okay. Okay, can you see my screen?
Yes, it's good. Full slide.
Perfect.
Okay. Yeah, thank you for the introduction, Rudy. Today we would like to basically give you a view of a different side of the meter. Most of the webinar I attended here is sometimes focused on the utility side. So what DERNetSoft is doing, and it's been focusing for the since the inception, the creation of the company, has been the behind the meter environment. And what we have seen all over the country and worldwide is an increase of use and deployment of distributed energy resources. Under this acronym, we can define PV, solar, energy storage, fuel cell, energy storage system, EVs, CHP, so any kind of local generator of energy or storage of energy. And our company has been focused on helping customer to identify opportunity or to optimize existing DRs. We built a software as a service offering, a platform that can actually automate the collection. Looking at the market and what has been the main challenges that prevent a commercial industrial customer, so we're talking about large customer usually, to become a prosumer. So what we've been focusing in supporting those large customers in transitioning from a status of energy consumer, so a consumer of energy, into a prosumer of energy, so energy production in their facility. And working with those customers, we can list few challenges that actually are preventing a large scale of those adoption, or let's say with the final goal to then support even the utility side or the front side of the meter, the other side of the meter, to actually use those resources into utility programs. One of the main standard is demand response, for example, but today we have many other type of services, energy or power, that the utility are always looking from asset behind the meter. So just what I would like to do is just really give you an idea of the challenges, and then I asked one of our main customer, Kaiser Permanente and Seth Baruch, to provide more in-depth description of the services and the value and the challenges, and how actually they were able to solve those challenges. I think the main goal of today is really to share our experience, the lesson learned, and being able to provide some of those information that may be helpful for you, or to focus your study, or to actually go back to your company and maybe try out and see if those are applicable in your environment. So I think that the main factor that one of the main factor that is preventing the adoption of these small size behind the meter resources is probably the lack of automation and digitization. These bring also the modeling, so the lack of a model of those resources that really can be in which data can be collected at the scale, and also without human intervention most of the time, and those resources can be really standardized and modelized to then being able to analyze. What we have found out working with our customers, that most of the time when you install, for example, a solar panel, is not always 100% a sure saving. We know that all these all these assets are basically small power plants, so they have to we have to be able to monitor and make sure that they are producing as expected. Also, they are in utility tariff rates, and they change over time. So you got to make sure that in a 20 years, 15 years lifetime of a project, you're able to track if any rate change, and make sure that you are still in the rate change. We have, and Seth can talk about that, but we found some solar array that were actually losing money and thousands of dollars a year because the utility change, and nobody were able to adjust and sign up for a new rate, which is really an email or a call to a utility rep. So it's an easy thing to do. And we found out that usually vendors are typically interested in selling their asset. They come, they present the project, everything is nice, they install, and then they goes away. But as I said, you need to have a way to collect the information over the lifetime of the project, and actually correlate those data from one asset to the rest of the site. Maybe you want to install a battery storage over a solar panel, but also you have a fuel cell. So those large commercial industrial customers usually have a campus settings in which you have a fuel cell and coupled with the solar and energy storage and a bunch of EVs. So it's really a complicated environment. Basically, what we were able to create with the platform approach is building an energy ecosystem that actually collect data from multiple sources, connect different stakeholders at the campus level or the company, the corporate level, making sure that data are flowing from different asset meters, PV, solar, energy storage. Those data are analyzed and are then shared to all the internal or external stakeholders. For example, now vendors can come on our platform and actually can get the data they need to make sure that their asset is running correctly, or they can get the data they need to evaluate the new asset to be deployed. So we, just to give you an idea, we were able to cover basic needs from, customer that are not or are thinking to go through this journey of becoming more prosumer at the single level, at the portfolio level, and then also having a suite of services that are used by customers that are already prosumer, so they already have DRs installed into their campus. And it's a really new industry. New assets are coming out, and we really are developing a bunch of services based on the customer needs that are not available, and actually are bringing a lot of value in terms of savings or efficiency. There's a few number of the company. I think I would like to go over and actually go into the presentation of how everything I told you is actually in reality used. And I really thank you, Seth, Baruch, for being here with me. I always think that having a customer that use the platform and our services is more valuable than me trying to convince you that we're cool. So I think he will provide a real example, a real life example of what are the challenges and how Kaiser Permanente will be able to solve that.
Great. Well, thanks, Alberto, and thanks everyone for joining today. It's a pleasure to speak to this group. So you can go to the next slide, Alberto. So I work at Kaiser Permanente, and for those of you who aren't familiar with Kaiser, and we don't have a big presence in Pennsylvania, we're mostly based in California, so this may be new to some people, but we are one of the largest integrated health plans in the country. When we say integrated, that means that we have the health insurance combined with the actual medical facilities and the doctor groups. So we've got the Kaiser Foundation Health Plan, which is the insurance plan, Kaiser Foundation Hospitals, which manages all of our buildings, and then the Permanente Medical Groups are the actual doctors that provide the care. So we have more than 12 million members. Actually, it's already a little bit outdated. I think our last year our operating revenue is just north of 100 billion. But really, for the purposes of this discussion, the key thing is that we have over 70 million square feet of occupied space. So we have 40 hospitals. We have 700 plus medical office buildings. Those are facilities that run 9 to 5, but aren't 24/7 facilities. We've got administrative spaces, data centers, everything down to MRI trailers. And so we have a very, very large footprint to manage the energy and water use of. So you can go to the next slide. Our core mission, of course, is to provide affordable, quality healthcare to all of our members, and to also, and this is important, to improve the quality of life in the communities that we serve. So what that means is, climate change is directly affecting our members' health. As I said, about 75% of our facilities and members are in California, a lot of them in areas affected by wildfire, smoke, and the health effects of heat stress. And so we know that climate change is having an impact on the health of our members. And so as a result, from the board on down, we have support from all parts of the organization to do what we can to mitigate our own impact on climate change. Hospitals are very energy intensive facilities. And so we have been since carbon neutral since 2020, which I can get more into kind of what that means, but we're doing everything we can to reduce our natural gas usage, which is our primary scope 1 emission source. With scope 2, we have actually now it's 122 sites with on-site solar, and the top we were talking about was mentioned the 300 plus megawatts of offsite renewables. And in terms of scope 3, we are actively engaged with our supply chain, the pharmaceuticals, the medical device companies, everyone that contributes to the supplies that enable us to provide care to our members. You can go to the next slide. So here's the challenge. We have there's a team of myself and 3 other people out of a staff of 200,000 and a footprint as large as Kaiser's. Only 4 people that are responsible for energy and water management across the enterprise. We have, in addition to the size of our footprint, we have the on-site solar. We've got the 40 plus sites that have fuel cells, battery storage, all different types of distributed energy resources, or DERs. And on top of that, we have now actually it's a little over 1,500 EV charging stations across many, many sites. We have multiple vendors providing these services across many, many different sites using different monitoring platforms. And we have a variety of different contracting structures to deploy, for example, on-site solar and fuel cells. Some of the solar we own directly. Most of the solar and fuel cells are we call PPAs, or power purchase agreements, that they're completely vendor financed turnkey solutions where we pay a price per kilowatt hour. It's like a little mini power plant on our property that we don't own. But we have many different PPA owners, and so it just becomes a very, very difficult challenge to manage all of that. Go to the next slide. But when there's challenge, there's opportunity. So we were actually able, with all of our different PPA owners and different vendors, to centralize all of our data using the DERNetSoft platform, combined with all of the 15-minute interval data provided by the utilities. Now, I've been at Kaiser for 10 plus years. When I first started, it was virtually impossible to get 15-minute interval data. You had to wait weeks at a time, and you got these very, very long Excel spreadsheets with thousands of rows. Now, with the Green Button program, for example, and others, we can just simply give authorization to send that data to DERNetSoft, and then they compile it into this platform that, when you actually combine it with all of the kilowatt hours from the fuel cells, from the on-site solar, from the battery owners and the EV charging companies, you can do some really, really interesting things that's actually having a real impact on how we use and manage energy. Go to the next slide. So this is sort of the journey we've had with DERNetSoft, and I'm going to get into some of these case studies in the next slides. But we started working with DERNetSoft in 2019, and the first thing that we did, and actually the reason why we started working with DERNetSoft, is we had a problem, which is that we noticed that our fuel cells, anecdotally, we just sort of looked at a couple bills. We had some complaints from sites that said, look, our gas bills are going up because our fuel cells are powered by natural gas, but it doesn't seem like our electricity bills are going down. And so we did some monitoring and saw that our fuel cells were oversized. They were producing too much electricity at night and selling back to the utility at a loss. We'll get more into that in a minute. Next, we moved up the curve there, and we started tracking all of our solar PPAs. So we were able to see, for example, where there may have been some billing errors or some other issues with our solar PPA bills. Again, across 100 sites, it's like a needle in a haystack. We didn't have the team to go audit every single one. So we actually had that audit function automated within the DERNetSoft platform. Then the next point going up, we actually saw that with this 15-minute interval data, we could actually, across hundreds and hundreds of buildings, see which sites were consuming too much electricity at night. And that's our nighttime setback program, which I'll get into shortly. And then all the way up, we were able to do this with natural gas meters, because some of our gas utilities are providing hourly gas meter data, and we're able to track the actual financial savings. That's the green line down there in the bottom from our fuel cell and on-site solar program. All of this just actually led to specific actions. And we didn't have this data, we would not have done those actions. We downsized some fuel cells. We were able to, get credits back from our solar companies. We're able to reduce our electricity use at night, and we're able to get, even more high-level approval to do more on-site solar. All of this purely as a result of having better information about how we use and manage both on-site solar and other DERs, as well as just, overall grid electricity. So we go to the next slide. So just very quickly on the fuel cell, now what you're actually seeing there is on the upper right is is the actual view of the platform. So I didn't have to look through thousands of cells in an Excel spreadsheet. I actually, through the DERNetSoft platform, had it all graphically shown to me exactly when and how much these fuel cells were exporting electricity back to the grid. That's when the output is below zero. And so we say, okay, well, in this particular site, there's too much net metering on the weekends. Well, okay, that's kind of life. That's something we could probably live with. But there are other sites where we were net metering all the time, and it just became clear that the fuel cells were too big. And so we went to our fuel cell vendor and we said, hey, it looks like you guys made the fuel cells too big. And they were, to their credit, very good partners. They're like, you know what, you're right. So we actually downsized some of those fuel cells and we moved capacity to other locations. And as a result, we saved millions of dollars. We actually got a couple of refunds from the fuel cell company, and they agreed that the fuel cells should have been smaller, and that we should also leave incentives for energy efficiency. So if you have a fuel cell that's overproducing all the time, what's the incentive of putting LED lighting in your parking lot? So we came to a real understanding as to how we would size these fuel cells in the future, which is it just made us smarter about how to intelligently deploy DERs, because sometimes too much of a good thing is not good. So you can go to the next slide. So that was our first use case with DERNetSoft, and how we're able to actually really lead to some actionable things just based on energy data. The second one is we actually automated our solar PPA auditing work. So with all of our solar PPAs, again, these are third-party owned and operated facilities, and we buy the output from them. And each of these contracts has a minimum requirement. In other words, if it's expected to produce X, and if it produces under 85% of X, we get a credit. And we're able to see here that at these particular locations, they were actually under the 85% expected production. Now, we could have gone through and gone through these bills ourselves. We could have waited for the vendor, the PPA owner, to come to us and say, hey, we're underproducing. And sometimes they did, but most of the times they didn't. And we had to go to them and say, hey guys, what's up here? According to our metrics, you're underproducing. And in some cases, they agreed. In some cases, we had to kind of go back and forth as to kind of what the data actually said. But in the end, we were able to hold their feet to the fire and make sure that they did everything they could to make sure the panels are clean, the inverters are working well, holding them to a slightly higher level of standard, slightly higher standard, where we can ensure that we're getting the maximum output from these on-site DERs as we were contracted for. So again, another use case that we were able to institutionalize across all of Kaiser through the DERNetSoft platform. You go to the next slide. So then we actually saw that in some cases we weren't actually saving as much money as we thought we would with the solar. So the key thing with what we do with our on-site solar is we put on-site solar wherever it can be demonstrated through analysis that the cost that we'd be paying the PPA owner per kilowatt hour would be at or below the price we'd otherwise be paying the utility. And so we should be saving money right away. But we were seeing in some cases, we were not necessarily saving money. Actually, sometimes we were actually losing money. That is to say, the price we were paying for per kilowatt hour of solar was actually slightly higher than what we'd be getting from the utility. Now, in California, as you may know, we have very, very high electricity prices. We got a lot of sun. And so on-site solar tends to be, and depending on the circumstance and the utility, but tends to be cost effective quite often. And so we were looking at this image for this one site there on the left, and we're seeing actually we were losing money. And it turns out that we were on the wrong rate. And that often happens. So sometimes some utility rates have higher per kilowatt hour charges and lower demand charges, or vice versa. And in some utility rates are more favorable to solar than to others. And so through the DERNetSoft platform, we're able to see, oh, actually, we could be on the 2E tariff instead of the 2B tariff. And again, I've got hundreds of sites to manage. I've got 44 different utilities. Each utility has dozens of tariff schedules that change every 6 months. There's no way I'd ever be able to keep track of that. But through this platform, DERNetSoft does keep track of it and says, okay, maybe you should switch from this rate to that rate. And as you can see there on the right, the losses went down quite a bit. And actually, in the end, switching over to the new tariff led this to a net cash positive project. So again, needle in a haystack. Wouldn't be able to do this on our own. If it's all automated through this platform, then we feel super confident that we are maximizing both the economic and environmental potential of these assets. Going to the next slide.
Giving a little bit of breather,
Sure.
a little breather to Seth, I'd like to add a technical aspect. So the platform, through use cases, we were able to basically build connectors that were able to connect with the different solar vendors' data platform and utility rates as well. So if you have one solar site, maybe you are able to do this analysis on a spreadsheet. But when you have hundreds of those resources, you need automation. So we were able to build all these connectors that are available for everybody, other customers as well, in order to collect those data, because that was the first step. Just automate the collection of data and then building all the analytics to do this kind of rate comparison.
So now we're just, again, continuing to augment, to expand what we can do with this data. So we were getting a lot of questions saying, oh, gee, we're installing all this on-site solar. It's really great. The members like it because they can park under these solar canopies when it's 100 degrees and shading, and it's good for the brand. But are we actually saving any money? And that was a question that I couldn't really answer. I had sort of anecdotal evidence. I had some sites here and there, that I could extrapolate to a larger population. But what DERNetSoft was able to do is across almost all of our solar sites where the data was available, they would be able to take both the cost and production data and you can see there on the right, what they did is they took the solar generation, and then they removed it, and so that they could build the alternative universe, the load profile that would exist without the solar. And then they could, using the current utility tariff rates and using the solar PPA price per kilowatt hour, they could tell me, for every day of the year across every single site, how much we would have been paying had the solar not been there, and how much we are in fact paying because the solar is there. And not only could they do that, but they could do it on a monthly basis. So I could go, to the facility managers who actually manage each individual site, and I'm like, hey, if you want to know how much your site saved last month, log on to the website, and you can see it there. And so what you're looking there with the blue arrow is what the monthly savings are for this particular site. And that is information that I couldn't even begin to provide. So, and what we could do is we could aggregate that across all the months, across all the sites, and I could go to my manager, who could then go to his manager and eventually to the CFO of the organization and say, yeah, the on-site solar program is saving $10 million a year, or saved $10 million last year. So a really good, handy tool, both at the site level and at the leadership level, to show not only are we doing better for the environment, but we're also keeping to that affordability mission by reducing our utility expense. So this is another example. Again, it's all sort of a stepping stone, right? We just kind of started from one and went, what more could we do with this data? Because we keep asking ourselves that question. And it turns out that, it's all the same data, but we're just able to do more things with it because we think creatively about how to, gather data from which sources and analyze it in different ways. So you can go to the next slide. So obviously with 15-minute interval data, we want to look at peak demand charges. So for those who aren't familiar, demand charge is what utilities charge for the maximum demand you hit in a month, even if that level was for like 15 minutes. And what utilities want to do is they incentivize consumers to reduce their peak demand, because that affects the peak of the utility itself and all of the headaches that go with meeting peak demand. And in the case of California, some utilities, the demand charges are almost as much as the per kilowatt hour charges. So if you can find, using 15-minute interval data, when your peaks are hitting, especially if they're abnormal, if they're outside the normal range, you could save yourself a lot of money. And so we are now across Kaiser, using this information to try and say, hey guys, if you can reduce your peak demand from, 2,400 kW down to 1,700 kW, you're going to be saving a lot of money. And so again, you could do this for one site, you could do it for a few sites, but you're not going to do it for 1,000 sites. And that's what this platform has been helping us be able to do. So you can go to the next slide. And so just building on that, the latest functionality that DERNetSoft has put in is actually doing hourly load profiles at each site, looking at both we call the gross load, which is basically, what is taken, what is consumed from the meter, plus what is generated on site. And then you take the meter load, which is basically only what we're taking from the utility. And you can see here that it's actually quite a bit different. You have sort of that we in California call it the duck curve, because it looks a little bit like a duck, but the decline in midday consumption from the grid because of the on-site solar at this particular site. I can't remember how much it is, but and so what this enables us to do, for example, not this particular site, but other sites, if you see that there's a big dip and you're exporting to the grid, as this site is during the peak hours of the day, this might be a good site for battery storage. So what you can do with battery storage is charge the battery when the grid is, when there's excess solar production, and then discharge the battery when the solar goes down. this duck curve doesn't have as big a neck as some other curves have at this particular site, but then you could actually then shrink the 5 to 7 p.m. times, and in California, that's when the solar goes down, all the natural gas peaker plants turn on, and that's when the wholesale market pricing tends to be quite expensive. So you can charge the battery with the solar, and then to just smooth out that curve, and then reduce the peak in the early evening hours. That will save you money as well. So again, we can now look at this. I could go on any site in the DERNetSoft platform, look at the hourly load profile, and I could probably slice it down. I look at that profile for the last month or the last 2 months and see maybe how things have changed, because load profiles do change, and they change sometimes for reasons that are maybe good, like installing electric vehicle charging stations. Well, that could have a big impact on our peak demand if those chargers are used quite a bit. So we need to have the intelligence to be able to figure out when this is happening where. So go to the next slide. And this is one of the most interesting case studies we've had with this data. So we were totally focused on DERNetSoft, DERs, distributed energy resources, supply side, on-site solar, wind, solar fuel cell stuff. But then one of my colleagues came to me and said, "Hey, this data is this 15-minute interval data is kind of interesting. Is there anything that we can do to look on the demand side? Specifically, like, I have no idea, because across our 1,000 buildings, who keeps their systems on at night. And so could you, Seth, figure out, look at across the entire year, across all of our buildings, what the ratio of the average load is at 4 a.m. to 2 p.m. And so and this is what you're looking at, some of the results, the initial results from that. So if you're looking at the closer you are to 100% down at the bottom, that's to say that virtually the building is consuming as much electricity at 4 a.m. as it is at 2 p.m. And at hospitals, you would expect something along those lines because they're 24/7 facilities. But at the MOBs, the medical office buildings, they shut down when everyone goes home, and they're off in the evening hours. They're unoccupied. So if you have an MOB that's at close to 100%, clearly there's an issue there. And then conversely, at some buildings, where the ratio is very low, that's pretty good. That means they're turning off the HVAC, they're turning off their lighting. And then you see the hospitals are actually in a very, very tight range. And that's, again, not surprising. About 2/3 of the load is used overnight as compared to during the day. So what we did is again, needle and haystack. We're able to find those buildings, those medical office buildings that had very high ratios, and say, what's happening here? And sometimes they come back to us and say, oh, well, we have a pharmacy, or we have a lab, or we have, there's some part of the facility that's on all the time. And we're like, okay, fine. But then there are some others where they're just, a doctor complained it was too hot or too cold, and then they changed the BMS settings and just left them there, and it ends up being that it's on all night long. So this led us, because this is really the lowest of the low-hanging fruit. I mean, it's literally turning your lights off when you leave for the night. And so we started to set up a program. You can go to the next slide. So we set up a program where, and you'll see the results in the next slide or two, but basically we just very aggressively went around and told people, please do what you can to change your BMS settings so your HVAC goes down, and most of the buildings have some sort of lighting control, but to the extent there are no lighting controls, turn off the lights, and then just all you're doing is saving money, and you're having really no impact on the on the doctors, nurses, or whatever. So then we noticed actually you could actually do this for gas too. That it turns out that actually some of our buildings use very, very high levels of natural gas in the evening hours compared to the daytime hours. And we had no idea why this would be the case. And you can see here just this crazy range. And so we started investigating about why and making changes accordingly. And this was very important for us because natural gas is a Scope 1 emission, and Scope 1 emissions are very hard to reduce. And here was a fairly straightforward way by changing the nighttime setbacks to reduce our gas usage. So you can go to the next slide. So what we did is we turned this into a KP-wide program. We got regional leadership. So we're divided in different regions, and we had to go like the leadership of each region and say, okay, Northern California, okay, Southern California, help us do this. We track, like the same way we track our EUI or water use intensity, and we track the way we track our utility expenses. We track for every single building what their load ratio, what their nighttime to daytime load ratio. And in Southern California, we had, and this is just the tip of the iceberg, a bunch of facilities that actually changed their settings, and then we were able to show the results, quantify the energy savings, and then market that to other other facilities. So we think that that this is, we could probably be doing this across hundreds of facilities, maybe not all the hospitals or all the labs. And then in Northern California, where we were seeing this, we've already seen a 6% drop in nighttime energy usage, and probably less than the 52 facilities we've done in Southern California. So where in Southern California, we have over $1.4 million in savings per year, and then a 12% reduction in natural gas use. Just for, I don't think we'll ever find an easier way to reduce our natural gas usage. So again, all started with our DERNetSoft platform. It all started when this guy came and kind of raised his hand and said, "Hey, I hear what you're doing with all this 15-minute interval data. Is there another way you can use it?" And it turned into this big program. So a really exciting use case that I think we're particularly proud of. You can go to the next slide. So this is just an example here of one medical office building in Inglewood, California, we see this often, where maybe systems are turned off on weekends or Sundays, but in this case, Saturday, the building was sort of, hardly occupied at all, and so we said, okay, please turn your building off on Saturday, and can you, on the weekdays, can you lower the usage up until really before people start coming to the building? So what you see there is the load profile where it's much tighter. The high energy usage is only during the key hours of occupation during the day, and then everything is shut down in the evening hours. From like, say, 10 p.m. when all the EVS and all the cleaning staff is gone, through 4 or 5 a.m. the next day, every single day of the week. So that I can't remember what the savings are for that one building, but it was in the tens of thousands of dollars per year, and you multiply that times hundreds of buildings, it really starts to add up. Go to the next slide. So this is just, I don't expect you to read the slide. I just think this is an impressive list. These are all the facilities and the savings that we got per facility, adding up to around $1.4 million. So so we're going to keep growing and expanding that program. Now it even gets a little more complicated because we have all of these EV chargers, and we have we're deploying battery storage and microgrids. And when you deploy battery systems, there's certain decisions you have to make about when you charge and discharge that battery that aren't always obvious. Like, do you run the battery focused only on shaving the peak to reduce those demand charges I talked about earlier? Or do you operate the battery so it operates so it focuses on charging when the rates are low and discharging when the rates are high? And because those two situations, low versus high rates and shaving the peak, aren't necessarily the same. So you kind of have to decide, and we don't have the ability to do that. So we kind of use the platform to tell us, where is the best way to use these battery assets. At the same time, you have these EV chargers, and sometimes they you install these chargers and they're not used for a while, and then the usage starts going up and up and up. And then when the usage gets pretty high, you install some more EV chargers, and that just totally changes the load profile of the building. And so we got to keep track of that. And maybe we make different decisions around charging and discharging the battery. But regardless, we need we need to track those hourly average load profiles across hundreds of buildings so we can stay ahead of the curve, literally, and change our operations accordingly. We can't do that on our own. We can't do that. Even if we could do it on our own, we can't do it across so many buildings. Because these are complex questions that, again, this is kind of the next evolution of how we're going to use the DERNetSoft platform with all of this data that we have, just using it in different ways to be able to kind of optimize all of our on-site resources and to reduce costs and optimize as much as possible. So this is actually one really sort of interesting story. I'll be quick here. This is once we installed our microgrid on Ontario, which actually just became operational a few months ago. But when it was under construction, the federal government, specifically CMS, actually changed its rules that allowed microgrids to provide backup power in addition to diesel generators. So diesel generators have been the backup source for hospitals since diesel generators began. But now you can use battery, solar, fuel cell resources to supplement or even potentially replace diesel generators. So this was a huge change that happened in large part as a result of our work in Ontario and the ability to show that microgrids can provide reliable backup, at least partially, if not entirely, for hospitals. So this is another change that sort of happened as this overall movement towards microgrid development at healthcare facilities. Go to the next slide. So I guess this slide kind of wraps up kind of everything that we've been talking about in terms of how to use data to ensure. I mean, we now have sites that have EV chargers, solar, fuel cell, and batteries. Actually, Ontario, that microgrid is a good example. So a lot of complex systems operating in a different variety of different situations, load situations, weather situations, and all of these systems are in a way sort of integrated, or at least need to communicate with each other to make sure that we're not exporting unnecessarily to the grid, that we're discharging the battery at the wrong time. I mean, this is kind of how a smart building is really developed. But to have a smart building, you can't just have all of these assets. All of these assets have to sort of coordinate, or at least to have access to all the other data, and that's kind of where the DERNetSoft platform has been for us. It can track all this data and tell us how we can better operate all of these assets, particularly when you got multiple assets on one building, which is what we want to have. We want to be able to have a building be as smart as possible, but we need to have the right data to be able to make the right decisions. And I think, Alberto, you going to take this one?
Yeah, I just want to map the previous slide into what we were able to build over time with our customer, which is really build an energy ecosystem in which now all the data comes in one place, and that's really help overcome one of the challenges, which is data collection and digitization. But that's actually enabled us to create model. So now we have standards. All the data coming from different sources are then in one place and also in one format. And talking about AI, all these fancy futuristic things, actually, that will work only if you can get good data on to start. So now we actually, having that, we are able to support and implement all the use cases that we have been seen from Seth. Through some machine learning and also AI that actually rely on those good data. So I think that now you can see different, DRs type distributed energy resources. You have different utility as well. You have different teams, internal and external, your vendors. And yeah, we were able to connect, more than, I guess now we're around 800 plus sites, more than 1,200 meters, 200 DRs. So start to become a good, kind of energy ecosystem or community, and bringing efficiency and a really short return on investment. But I think the main message is that, we saw the challenges and now we are really building a future to overcome those challenges. And then going to the result, being able to support, Kaiser customers such as Kaiser on their journey.
Actually, one comment I make on this slide is that $3 million per year from the on-site solar. Actually, in the last year, it went up to 10 million. And I think partly that it's two things. One, we added a bunch more sites, but two, the utility rates in California just skyrocketed. And it was just a very high kind of year-over-year increase. So, and we expect that delta to kind of increase over time as the escalation rate for on-site solar is very, very small, like 2% or something. And in some cases where we own the solar, there's no escalation at all. But then you've got utility rates going up at 10, 15% a year or something. So, that we expect to see that number continue to grow quite a bit over time. And so this is just kind of an idea that I've been trying to push with some of my peers across the industry, and that is, is it possible to basically do what we did at Kaiser, but across multiple systems, where we could share data and experiences? And so if we had this platform, if DERNetSoft was at all these other different healthcare systems, both inside California and beyond, could there be sort of a central data hub where we could kind of all learn from each other about, these use cases? Are there other ones that we could be developing? Are there, could we be slicing and dicing this data in a different way to come up with, other solutions, other use cases? So that's something I'm working on. But I'd like to sort of see this go beyond Kaiser and to have a multi-healthcare system approach to this. And if there are such health systems in Pennsylvania that would be interested in coming with us on this journey, that would be great. But the nice thing about healthcare is that I guess we sort of compete, but we're all very localized, so we don't really compete with healthcare systems in other places. But even where we do compete with other healthcare systems, we all have sort of the same mission, and it's not, bitter. It's not like Coke and Pepsi. We're all sort of friends, especially on the facility side. So anyway, I hope to build on this concept in the future because I think there's something there.
Yeah, and along the same way, also having a platform approach on the technical side allows those healthcare providers to be connected and basically create a larger ecosystem that doesn't work only within the healthcare provider system, but it goes and share data with the other healthcare system, or to be more effective and sustainable. I think that was the last slide. I think those are our contact. If you want to connect with us, happy to answer question offline, and those are our email, and you can contact us. Feel free to do. I think yeah, Rudy, before going to question, maybe I just want to wrap up. I want to thank you, Seth, for the long presentation and sharing all the use cases. My main takeaway here is, we introduced the matter with the challenges. So we see really an improve in adoption of distributed energy resources and new technologies, and that comes with challenges. So having a digital and platform approach we're able to actually support all the use cases and the journey that Kaiser and other customers are taking to a more sustainable future. And having a kind of standard software approach as well was able for us for DERNetSoft, we were able to actually build API that were able actually to easily integrate with existing system and being able to be really scalable and effective, also cost effective in some ways.
Good. Thanks a lot, guys, Seth and Alberto. So now your timing is perfect. So we've got time for questions from the audience. First, I'd like to kind of solicit questions from the students before we get to the general audience. So if you don't mind, you can stop sharing. Okay, good. So I'll first of all solicit students in the audience to ask questions. So before you ask your question, please unmute yourself and then introduce yourself and then ask the question, please. Questions from students?
Right now, I don't think we got any questions.
No questions from Adam's group there? Okay.
Not right now, but we'll let you know.
All right. How about the remote students?
Sure, I have a question. I'm a student. My name's Kevin, in the ESE program. What challenges arise with trying to forecast adoption rates of different DER technologies? I know kind of like what comes to mind is EV demand and how it's kind of fluctuated in the past few years. Whether that's maybe just in consumer perception, but kind of from viewing it as a resource that you may be tapping into in the future. How do you forecast that into your calculations?
Well, so I guess we I'm not sure if this answers the question, but for our legacy facilities, we have very good data on what we've used in the past and what we've consumed in the past, and so we can size our solar appropriately. So it's not, I mean, and of course, as I indicated with the fuel cells, it still wasn't perfect. Sometimes the fuel cells were still oversized. But we basically look at the historical load curve for our facilities. And sometimes there's a trend line. In general, plug loads increase, usage increases, hours stay longer, or facilities are open longer. So in general, electricity usage at sites typically go up over time, not a huge amount, but some. And it might be knocked down by, we put LED lighting in the parking lot or something, so there's energy efficiency. But in general, is sort of a slight increase in energy use at our facilities, and then there's expansion. So you put in a new wing of the hospital, and that changes everything. So, but we, the biggest constraint of deploying, particularly solar, is not like how much load it's gonna provide or reduce, but physical space. So just the size of the parking lot, the size of the roof, and you put enough solar on so you kind of max it out, but it usually doesn't cover, it's a third of the demand of the building or something like that. So usually there are other constraints that impact, and parking, physical space, etc., that impact the type of or the quantity of DER that we deploy.
I would add on top of what Seth said, federal policy are also impacting the evaluation of DRs and also technology availability. So I think Seth can mention, new type of battery technology that are not lithium based. So those are all elements that, based on your specific project, can impact the selection. Utility rate, incentives, those are other elements that can make a project feasible or not.
Great, thank you.
We have a question here.
Hi.
Hi, I'm Selena. I'm also an ESE student. I was wondering, since you guys mentioned how hospitals are 24/7 and difficult to find areas there to cut down efficiency, but offices you can like turn off the lights after hours and stuff. Are there any things that you can do for hospitals and emergency facilities that are 24/7 that wouldn't interfere with the quality of care?
Yes, absolutely. So you can put in more efficient equipment. You can like LED lighting. We're doing LED retrofits kind of all the time. So just part of the course. New chillers, that kind of thing. We are experimenting. We have a lot of hospitals that use continuous ventilation, as that's sort of been historically code. But if you go to variable levels of ventilation and you kind of downsize, or you run the chiller, you run the equipment less when not needed. So there's a lot of different energy efficiency strategies you can deploy for hospitals, and it's good because it's hospitals are very energy intensive, and they operate all hours of the day, at least in some capacity. I mean, some things like the MRIs and the energy intensive pieces of equipment, there's not much you can do about that. But in terms of the overall operations, yeah, we've seen that if you get 10-15% energy reductions in a fairly straightforward way in most hospitals.
Awesome, thank you.
Any questions from the audience?
I think there is a question on the chat.
Okay.
Ryan is asking if our technology can be implemented outside the healthcare industry. Actually, yes. So we have, I would say, we're cross industry because energy, sustainability reporting is used everywhere. And healthcare also have hospital, but they have lots of office spaces, warehouses. So those are type of building that are used across any industry. And so I would say that we are definitely working with customer in different industries. And also across the United States and actually worldwide, because we were able to scale the management of different utility between rates, program, policy, incentives, all this kind of stuff. So,
Questions from the audience? Ask it orally. Introduce yourself, or you can put your questions in the chat box. Let's see, there's one new. So Seth, real quick, you had a staff of 4 people doing all this?
Yeah, so I have a team of 3 people. So myself and 3 other people are responsible for running this overall program.
Remarkable. And did you say, what were your savings once you were able to get to the bottom of these numbers? You cited something up in the beginning, the savings were X million. What was that?
So last year, the solar program saved $10 million.
Just the solar program.
Yeah, yep. And that was, again, there's a big jump because actually the last few years, utility rates in California, where most of our solar sites are, just went up quite, quite a bit. I have numbers. I don't have that off the top of my head, but we have similar levels of savings from the fuel cell program. Again, the kilowatt hours from the fuel cell plus the cost of natural gas to run those fuel cells is still less on a per kilowatt hour basis than most of the California utilities.
And so you expect to have these kind of cost savings in future years too?
Yes, we do. Yeah, one thing you can always tell about utility rates is they never go down.
It's okay.
They always go up at just at different rates.
Right.
And that's actually especially true in, I was gonna say, it's especially true in California because there's so much investment going on to fireproofing the system, putting more infrastructure underground, hardening. So it's utilities continue to ask for more higher rate increases at the Public Utility Commission.
I assume that you also obviously make gains by demand response, using demand response to the grid. Is that done seamlessly? I mean, are the hospital staff even aware that of
So
not having the source?
it's interesting. We do not do hardly any demand response.
Or you don't?
And the reason, and we've tried, and the reason is because there's so much resistance at the local site level to doing it, like even turning the thermostat down a couple degrees, or up a couple degrees, it's sort of anathema to how they operate. They're just scared to death of anyone on the medical side complaining it's too hot or it's too cold. So and honestly, the incentives from the utilities have been too small for us to kind of go site by site and ask them to consider this. It's a lot of effort for not a lot of gain. There's one evolution in the demand response area that we may participate in, and that is running diesel generators. It's not really demand response, but it's running our diesel generators during times when the grid is stressed. So if it's like a really hot day and there's not enough capacity on the grid, there is a program that we're contemplating where if we turn on the diesel generators, that we get payments for that. So that is one area of demand response that we're considering. But other than that, we haven't done any DR.
Other questions from the audience?
There is a question from DC. Is maybe Seth, you can talk about this. Outside California, how variable are the savings?
Yeah, so we have about 75% of our facilities in California, and the others spread across 5 or 6 different states: Hawaii, Washington, Oregon, Georgia, DC, Maryland, Virginia. And so each individual is so small, each individual state, and Colorado too, I forgot. So generally the electricity rates are lower in those other states. And so we have trouble making solar pencil. And we do have some solar projects in, like, for example, in Maryland, but the savings are quite low. I mean, it's still good to do, but it's not a high in terms of the economic benefits, not very high. And so Hawaii is really the only place other than California where we are aggressively doing solar and battery storage because the utility rates are even higher than California. But it's hard to make anything work, for example, in Georgia when it comes to DERs. So we always look at opportunities and maybe where costs can come down at some point. But really, so much of our work is, I would say, very much concentrated in Hawaii and California.
Questions for Alberto and Seth?
Yeah, so the question there, do state incentives play into your Yes, we I mean, it's not a huge part of it, but there are state incentives available, we take advantage of them. There are state grants, for example, in California for battery storage, which we have taken advantage of. The battery for the Ontario microgrid was financed through a state grant through the California Energy Commission. So when and then there's a lot of grants for EV charger installation. So that has driven, no pun intended, deployment of EV chargers in certain sites, particularly in Southern California, where there's a lot of utility money going to help finance the installation of EV charger stations. So I actually would say that when it comes to state and utility grants, the EV charging program is the one that's benefited the most from that.
Questions for Alberto and Seth? Another question? When you talk about
locking them out during peak hours, when you say locking out, when you say locking them out, who's them?
Alexander, if you want to answer that, yes.
I mean, for the chargers, yeah. So no, we haven't turned off the chargers. We do have an option to do that. We also have an option to throttle them down so that the rate at which kilowatt hours are dispensed to electric vehicles is reduced. So far, we've decided not to do that because that might piss off the EV owner. But that is definitely a strategy we'll look at in the future if other solutions are not available and if peak demand charges are driven by through the use of EV chargers, but we haven't gone there yet.
Thank you. Questions for the speakers? Any more questions? Well, there are no more questions. Thank you again, Seth and Alberto. And as I said at the beginning, Alberto has been a strong supporter of the ESE program by offering different capstone projects, and we and with the help of John Matranga, who was with OSI Soft and moved on to another company. I think they have been very critical as far as providing the capabilities for our students to be involved. So that's really great. Go ahead. Appreciate that, Alberto, and we will join you 2 weeks from now for the next ESE seminar, and that will be the penultimate seminar for the semester. So it's been a very informative session so far. Thank you all. See you soon in 2 weeks, and thank you again, Seth and Alberto.
Thank you Steve, for the opportunity, and thank you, Seth.
Thank you. Yeah.
Thank you.
Take care, everyone. Yeah. Bye-bye.